It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome back to lesson 2, where we're going to continue looking at our properties of exponents, where we're going to kind of extend it to look at what if I have any integer, which means positive or negative numbers, and what if I had an exponent of 0. So again, this is review from 8th grade. We're just making sure that we understand our properties of exponents because we're going to use them going forward in our mathematical journey. So let's look at this here. Try this opening exercise. So let's pause the video and try this opening exercise here. Rewrite each of these in simplest form. So x to the 7th times x to the 5th. So our property here is that to find a product, I find the sum of the exponents. So I get x to the 7 plus 5 is 12. I've got 7 x's and 5 more x's, and exponents are repeated multiplication. So I have 12 of them being multiplied together. Here I have a power to a power. Here I have a power to a power 3 squared. X to the 3rd squared is a multiply x to the 6th, because that's really x to the 3rd times x to the 3rd. And then finally here I have a power to a power, but everybody gets that exponent. So you get x to the 15th, y to the 9th. So hopefully that was a quick review from lesson 1 of some properties, and let's look at some new properties of exponents here. So let's rewrite each of these by expanding them out a little bit. So x to the 5th is really 5 x's being multiplied together over x squared. So notice here I have common factors on the top and bottom, so all of those terms divide to 1. Goodbye, 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 goodbye. And we're left with x to the 3rd. Here I have 3 to the 10th, so here we go already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 3 to the 5th. And then all I have to do here is divide out common factors. Goodbye, 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 goodbye. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I lost 5 on the top, 5 on the bottom, and I'm just left with 3 to the 5th. And then finally, one more time here, x to the 8th, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8 over x squared. So I'm going to divide out common factors again from the top and bottom. And I'm left with repeated multiplication where there's 6 of them, so x to the 6th. So looking at this, how can I generalize this property? If I have a quotient, if I'm dividing, how could I quickly simplify this expression? Hopefully, you said you end up subtracting the exponents. 5 minus 2 is 3. 10 minus 5 is 5. 8 minus 2 is 6. So it's x to the a minus b. So when I find a quotient, when I'm finding a quotient, we end up subtracting the exponents. To divide, we actually subtract the exponents to make it one term. So let's apply this property to simplify x squared over x to the 7th. So the property says all I have to do is subtract the numerator and the denominator, which leaves me with x to the negative 5th, which is just bizarre because my concept of an exponent is repeated multiplication. How do I multiply x by itself negative 5 times? Well, you don't. It doesn't make sense. So here's really what's going on here. So we're going to have to kind of extend our properties of exponents to a new meaning. What do I do when I have a negative exponent here? That's my question. How do I deal with a negative exponent? Well, that's what we're going to talk about right now. I got 1, 2, 1, 2, 3, 4, 5, 6, 7. I'm going to divide out common factors, but notice more of them are in the denominator. So I have 1 over 1, 2, 3, 4, 5, x to the 5th. So these two expressions should be the same. X to the negative 5th equals 1 over x to the fifth. So let's write this here. X to the negative fifth is really 1 over x to the fifth. So what did that negative do? It looks like that negative is taking the reciprocal. The negative exponent there means we're going to talk about this a little bit more, means I'm going to take the reciprocal. We're going to talk about how do I deal with a negative exponent. It looks like I'm flipping it here and getting rid of the negative. So before we talk about what those negatives mean, let's talk about 5 to the 0. Again, it's something else that's weird. I have 0 5's being multiplied together. It doesn't make sense. So let's look at this statement here. Why is this sentence true? 5 squared times 5 to the 0. Well, when we multiply, we add. 2 plus 0 is 2. So 25 times what gives me 25? 25 times 1 gives me 25. So that's telling me 5 to the 0 has to equal 1. It's weird. I know it doesn't make sense. It doesn't follow our standard intuition of exponents. But when I have a 0 power, it equals 1. Let's do 3 to the 4th over 3 to the 4th. So here we go. 3 to the 4th is 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. So I'm going to divide out some common factors. Goodbye, 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 goodbye. And I'm left with, well, when I divide out common factors, I get 1 over 1, which is 1. But the rule is to subtract the exponents. 4 minus 4 is 0. So notice I got 3 to the 0 has to also equal 1. The value of that expression is 1. 81 divided by 81 is 1. So 3 to the 0 also equals 1. And finally, one more time, we know exponents are repeated multiplication. 2 times 2 times 2 times 2, 2 times 2 times 2 times 2. So each time I keep dividing by 2 to get down, to lose an exponent, I keep dividing by 2. So to make the jump from 2 to the first to 2 to the 0, well, what's 2 divided by 2 is 1. 2 to the 0 is 1. So apparently, anything to the 0 power is always the number 1. X to the 0 power is 1. If I have x to the 0, I get 1. If I have 10 to the 0, I get 1. If I have chicken nugget to the 0, I get 1. So anything to the 0 power ends up being the number 1. There's a couple ways we can figure it out. This equation had to be true. When I divided it 2 different ways, I got 3 to the 0 is 1. And if we follow this idea of repeated multiplication, it has to be 1 because I keep dividing by 2 to lose an exponent. So using the same idea now, let's talk about negative exponents. So we already kind of talked about negative exponents. 5 to the 1 is 5. 5 to the 0 we just figured out is 1. Well, 5 times what is 1? Well, 1/5. That 5 to the negative 1 has to be 1/5 because 5 times 1/5 gives me 1. So again, this follows that idea of that negative there is telling me to take the reciprocal. It's telling me to flip it and move it into the basement. So that negative exponent goes away and it throws it in the denominator. So 5 to the negative 1 is really 1/5. Same idea again. 2 to the 3rd is 8. I don't know what that thing is. 2 to the 0, anything to the 0 power is 1. So what has to go in there? Well, that has to be 1/8. So 2 to the negative 3 has to be 1/8. Well, where did the 8 come from? Well, the negative is going to throw me in the denominator, and 2 to the 3rd is 8. So notice that negative, all we're doing is getting rid of that negative exponent. We're flipping it, and then you make it positive, 2 to the 3rd. So it's 1 over 2 to the 3rd. Same idea here. I can use repeated multiplication. I'm dividing by 2. Divide by 2. Divide by 2. If I divide by 2, that's 1/2. If I divide by 2 again, that's 1/4. Well, 1/4 is 2 squared. If I divide by 2 again, that's 1/8. That's 1 over 2 cubed, right? 8 is 2 cubed. If I divide by 2 again, that's 1/16. That's 1 over 2 to the 4th. So that negative exponent is just turning them into reciprocals. I'm flipping it and making the exponent positive. So x to the negative b over x to the negative b is 1 over, take the reciprocal, of x to the b. I made the exponent positive and threw it in the denominator. All right, hopefully this was a good review, and now let's do a couple of practice problems and I'll let you go. So which of the following is not equivalent to 5 to the negative 2? Well, the first thing I notice is that's 1 over 5 squared, right? The negative throws me in the bottom. So choice 1 matches up. Well, what's 5 squared? 1 over 25. That matches up. And if I type that in my calculator, I'll get 1/4. So which one's not equivalent to it is 1/10. It's not 1/10, it's 1/25. So this is which one is not equivalent to it. Write an equivalent expression to this that does not use exponents. All right, so I got a power to a power. So let's deal with that. Power to a power is multiply. Power to a power, we multiply. Well, what do I do when I divide? I end up subtracting. 6 minus 8 is negative 2. Well, what does a negative exponent do? It flips me. 1 over 5 squared, which is 1 over 25. So I can quickly simplify that expression by using my properties of exponents. And finally, last one here. Simplify this expression using only positive exponents. All right, so the first thing I notice is I got this squared in the denominator. So let's deal with that. 2x to the third, y to the negative 7 times 2x to the third, y to the negative 7. So what's really in my denominator there? Well, it's 4x to the 6th, y to the negative 14. And that's still up top there. All right, 16 divided by 4 is 4. Here I have to subtract. Negative 4 minus 6 is x to the negative 10. And then here I have to subtract. You got to be really, really careful because I'm subtracting away negative 14. 5 minus negative 14 is really 19. Y to the 19th there. So you got to be careful when you're subtracting here. It's top minus bottom. You got to watch out for double negatives. Well, where does this x to the 10 really live? Well, it can live in the bottom. It can live in the denominator, and that's how it makes it positive. That negative 10 throws it in the denominator. So you have to know your properties of exponents because they're going to follow you through your high school career, and you got to watch out for that negative and 0. Anything to the 0 power, chicken nugget to the 0 is 1. What if I have chicken nugget to the negative a power? Well, it's 1 over chicken nugget to the a. I got rid of the negative by just flipping it and putting it in the basement. All right, folks, I'll see you in the next video.